Hey everybody, in this video we are looking at example 18 on a playlist full of pre-calculus final exam review problems. We are going to determine the amplitude, period, phase shift for y equals sine 2x plus 1, and we will graph one period of this function. So the first thing I did before we even get started is I rewrote this problem to really highlight and indicate what A, B, H, and K are. So A over here is 1, and 1, absolute value of 1, is the amplitude. So the amplitude or vertical stretch is 1, so basically it is standard. Period. The period is the horizontal length of one full cycle. The formula for the period for sine, cosine, secant, and cosecant is 2 pi over b. For tan and cotan, it is pi over b. And we will find 9 tick marks as opposed to 5, and we will always just graph 2 cycles for that for sure. But we're also going to graph 2 for secant and cosecant later in this playlist. So the B value is going to be found inside what I call the crazy house, and that is your horizontal stretch or compression. It's the opposite of what you would think. So that 2, even though it's bigger than 1, is not a horizontal stretch, but instead it is a horizontal compression, hence us dividing by that value instead as opposed to multiplying. 2 pi over 2 means that the period is pi. Always after that, I jump into finding a quarter period, which is 1/4 of that. So I will divide by 4 or multiply by 1/4. So I have the quarter period ready to go. And that is what we add to get the other 3 after we have our first tick mark. The phase shift is essentially giving me my first tick mark, and that is going to be 0 in either direction, okay? No shift. This is not being shifted left or right. So that means I can go ahead and label my very first tick mark as 0. Pi over 4, the quarter, is how much I'm adding each time. So 0 pi over 4 plus pi over 4 is 1 pi over 4. Next will be 2 pi over 4, which it's a little squished down there. I guess I'll pull it up and put it back, right? 2 pi over 4. 3 pi over 4, and lastly is 4 pi over 4. Of course we can reduce, but this makes it easier for writing out domain and range for things with asymptotes, yada yada. Good enough for now. Great. After this, what else can we find? Well, my plus 1 at the end, that is your plus k, that is your vertical shift, and that is your what we call sinusoidal axis, or you might refer to it as your midline. Being that that is at 1 and my amplitude is at my amplitude is 1, then this will be 1 plus and 1 minus the amplitude amount, which is 1, 1, and then that means we are equals 2 for this, equals 0 for that. That's how we come up with those values. So 2 will give me max values, 1 is my midline, 0 will give me min values. Got it. Also, this is a positive sine wave, so I talked about this in another video. If you need the lesson, go into the description box for the lesson on how to graph sine. But the sine wave is shaped like this. It also kind of looks like a turned around inside out S. Like if I kept going, I can write SIN. Do you see it? Like sine theta, like that. Use your imagination. Okay, so there's the sine wave. There are my 5x values all labeled. Those are my 3y values all labeled, and I am good to go. By the way, that was the phase shift right there, if you were wondering. So that's like your H, and this is your K, all that good stuff. So that is the end of this video. If you got it good, and you feel all right, give a thumbs up. If not, go ahead, thumbs down, interact, question, comment, concern, feedback, or request, go in the comment section, check the description box. I updated almost all the description boxes on this playlist recently, so there should be a lot of links and detail in there. That's it for now. Adios.